Welcome to the training module on an overview study of the MEMS sensor accelerometer. This training module will introduce about basic working principle and other interfacing details of the MEMS device. The LIS331DLH is an ultra-low power, high-performance 3-axis linear accelerometer belonging to the Nano family, with digital I2C and SPI serial interface standard output. The device features ultra-low power operational modes that allow advanced power saving and smart sleep to wake up functions. The LIS331DLH has dynamically uses selectable full scales of 2, 4, 8G and is capable of measuring accelerations with output data rates from 0.5 Hz to 1 kHz. The device may be configured to generate interrupt signal by inertial wake-up, free-fall events, as well as by the position of the device itself. Low-G MEMS accelerometers are widely used for tilt sensing in consumer electronics and industrial applications, such as screen rotation and automobile security alert systems. Another popular application for low-G accelerometers is tilt-compensated electronic compasses for map rotation and personal navigation devices. Here is the block diagram of the LIS331. This page gives information about the terminology for MEMS sensor like sensitivity, 0G level and sleep to wake up. The ultra-low power LIS331DLH digital accelerometer is housed in a 3x3x1mm LGA 16 package. It has an I2C and SPI digital serial interface for 3-axis acceleration outputs, so no external ADC chip is required. It also features a dynamically user-selectable full-scale measurement range of 248G, with output data rates from 0.5 Hz to 1 kHz. The LIS331DLH has been factory calibrated. The device has 2 pins which can be activated to generate either the data ready signal or the interrupt signal. The functionality of the pins is selected acting on bit I1 of the CFG bits of the control reg 3 register. The data ready signal rises to 1 when a new set of acceleration data has been generated and is available for reading. The signal is reset after all the enabled channels are read through the serial interface. The LIS331DLH can operate in the following 4 modes, which can be selected through the configuration of Control Register 1 and Control Register 5. The power mode and data rate bits of Control Reg 1 register are used to select the basic operating modes: power down, normal mode and low power. The turn on bits of the Control Reg 5 register are used to enable sleep to wake, which is an advanced mode involving the interrupt configuration. In normal mode, data are generated at the data rate selected through the DR bits and for the axis enabled through the Zen, Yen and Zen bits of the Control Reg 1 register. Data generated for a disabled axis is 0. In power down mode, almost all internal blocks of the device are switched off to minimize power consumption. The LIS331DLH provides embedded high-pass filtering capability to easily remove the DC component of the measured acceleration. It is possible to independently apply the filter on the output data and/or on the interrupts data through the FDS, HPen1 and HPen2 bits of the Control Reg 2 register configuration. The LIS331DLH interrupt signals can behave as free-fall, wake-up or 6D orientation detection. When an interrupt condition is verified, the interrupt signal is generated, and by reading the interrupt 1 SRC and interrupt 2 SRC registers, it is possible to determine which condition has occurred. FF or WU interrupt generation is selected through the AOI bit in the interrupt configuration register. If the AOI bit is 0, signals coming from comparators are put in logical OR. When an interrupt condition is applied, the interrupt signal remains high even if the condition returns to a non-interrupt status until a reading of the interrupt SRC register is performed. The LIS331DLH SPI is a bus slave. The SPI allows us to write and read the registers of the device. The serial interface interacts with the outside world with 4 wires: CS, SPC, SDI and SDO. CS is the serial port enable, and it is controlled by the SPI master. It goes low at the start of the transmission and goes back high at the end. SPC is the serial port clock, and it is controlled by the SPI master. It is stopped high when CS is high, no transmission. SDI and SDO are respectively the serial port data input and output. Those lines are driven at the falling edge of SPI and should be captured at the rising edge of SPI. The SPI read command is performed with 16 clock pulses. Multiple byte read command is performed, adding blocks of 8 clock pulses at the previous one. The ST7 USB microcontroller included on the board allows communication between the sensor device and the PC. The user can interact with the hardware through the graphic user interface provided with the kit. It requires the installation of a dedicated driver which is included in the installation pack, together with a graphic user interface which allows simple interaction with the sensor.